In the section 7.2, actually, not 7.5, it's a little typo here. Let's discuss area between the two curves. It's very similar with area under the curve, but what if we have two curves instead of one, let's say? What if we have f of x, let's say, is the top curve, and g of x is the bottom curve? Well, we can actually easily put a little rectangle here and define the integral. So the height of the rectangle would be the difference between the two functions. Typically would be the top function minus the bottom function, and the width would be dx, and then we can have integral from a to b. So you'll notice this is the area, integral from a to b, f of x minus g of x, again the top minus the bottom, dx. And so we can do this very similar with a definite integral like we've done in the previous sections. So also, we need to make sure that the area is positive. You can do it in one of two ways. Either graph the functions and make sure that you know which one is the top one and which one is the bottom one, or put absolute values around the integral, and that way you can actually make it positive. So let's start with this problem number 9 in that section. Find the area of each indicated region. Let's say we have y equals x squared and y equals -1 in the interval from -1 to 1. Whenever possible, if the functions are easy enough, graph them because it's easier to visualize. So we're trying to find the area between the two curves. So it's kind of like right here, if I can attempt to draw it. I'm doing it with my mouse. I think I've gone a little overboard here, but I had to erase the previous one. But let me try again. We're trying to do the area between the two curves. So how do we set this up? If you notice, it's the integral from -1 to 1. Since the x squared is always the top function and -1 is always the bottom, it's clear. They never intersect, they never switch places. Then we can just do the interval as the whole from -1 to 1. We do not have to break it up. But occasionally we will have to in the later sections. So then it would be x squared minus -1, so we have to subtract the bottom function, in this case -1 dx. But minus a negative becomes a plus, so it's actually x squared plus 1, and then we can integrate, as in previous section, find antiderivative, x cubed over 3 plus x. From -1 to 1, we plug in the top number first, and then the bottom number. Again, let's be careful with signs here. It's just 1/3 plus 1. The -1 cubed again becomes -1, and then we distribute the negative, switch the sign, actually becomes 1/3, and similarly minus a negative becomes +1. So again, we get 2/3 plus 2, which is 2/3 plus 6 over 3, which then will get 8 over 3. All right, now let's find the area between y equals -x and y equals x from 0 to 2. Again, we can draw this out. And from 0 to 2, we know that they're both 0, and then y equals x actually goes in positive direction and ends at 2, and y equals -x goes in negative direction. So it looks like pretty much like a triangle. But we can set it up the same way. Again, it's 0 to 2. The top function is x minus the bottom function, which is -x, which is, again, they actually combine, and it becomes 2x dx. And which we integrate, which becomes x squared actually from 0 to 2, and we can plug in 2 and 0 and we get 4 is the final answer. And again, similarly with y equals x and y equals x squared from -1 to 1. Now it's very interesting when we draw this out. Y equals x squared is this parabola and y equals x is a straight line. But notice from -1 to 1, x squared is the top function and x is the bottom because it's negative. But from 0 to 1, they actually switch places. The x is the top function, actually. Let me pause it and actually write. I've attempted to write this out to kind of help you see it. But once again, y equals x is the top one and x squared is the bottom one. And I can actually show in class how you can graph it in graphing calculator and know which one is the top one and which one is the bottom one. And they do cross at x equals 0, so sometimes they do cross and switch order. So in order to keep the area positive, we can break it up, or again, you could put absolute value, but you still have to break it up. And if you put absolute value, then you don't need to worry about which one is the top one. But I think it's easier to keep it positive if you just realize which one's positive. So from -1 to 0, x squared is the top function, so the integral should be x squared minus x dx. And then from 0 to 1, the x is the top function. They switch, so it becomes x minus x squared dx. You do have to separate them, otherwise you'll get part of the area as negative, and you'll actually get a smaller answer than you should, or sometimes even 0 if they subtract completely. So you do need to break it up. That's why drawing is so important. So, and then the integral is very similar. So you'll get x cubed over 3 minus x squared over 2 from -1 to 0, and the other way around from 0 to 1. And again, just start plugging it in because they both have x in it, and the top part is 0, minus, and then we'll plug in -1, and then plus, we'll plug in 1, and then subtract 0. And again, you'll notice how they combine instead of subtracting. So again, -1 cubed becomes -1/3, and times negative becomes +1/3. And then -1/2 squared, it actually becomes positive as well, because -1 squared is positive, and then negative times negative becomes positive as well. And then 1/2 is positive on the other side, and then it's -1/3. So 1/3 actually cancel out, but 1/2s combine, so the answer is 1. Okay, moving on. And what if we're trying to find the area between y equals x cubed and y equals x to the 4th? Since the interval is not indicated, it's not always indicated, we can solve for points of intersection, and we'll be able to draw the graph. It's maybe hard to see which one's the top one. Again, you may have to make one of them bolder in the calculator, and again, I will show this in class. But how we can solve for points of intersection: set them equal to one another, x to the 4th equals to x cubed, move x cubed to the other side so we can make it equal to 0, because we can actually pull out x cubed and factor it. So we'll get x cubed equal to 0, which means x equal to 0, and then or x equals 1. So it's really, the region is between 0, 1. And this is actually a 1, but we're talking about y equals x cubed is actually the top function versus y equals x to the 4th. Why is that? Because between 0 and 1, the higher the power, the smaller the function. Because if you're talking about fractions or decimals that are smaller than 1, the higher the power, the smaller they are. Because if it's a fraction, let's say 1/2, you square it, you'll get 1/4. If you cube it, you'll get 1/8. So you'll get bigger denominator. So you'll get actually smaller fraction or answer. So we integrate from 0 to 1 the intersection points, x cubed, the top function, minus x to the 4th. Again, if you use absolute value, then you don't have to worry about which one's the top one. Then you'll get negative answer, and then you can always take absolute value of it. So if you do end up switching it by accident, you get a negative answer, think about putting absolute values there. But you do have to make sure the functions intersect, and you know where they intersect because they can switch. And if we integrate it, we'll get x to the 4/4 minus x to the 5th over 5 from 0 to 1, so which is 1/4 minus 1/5 minus 0. And if you cross multiply, you'll get 5/20 minus 4/20, so you'll get 1/20 with a common denominator. And similarly, with y equals x and y equals x cubed, you can find intersection points. Again, you can set them equal to each other. Move the x to the other side, pull out the x. In this case, we have x squared minus 1 left over. So there's actually 3 intersection points, because you can factor x squared minus 1 into x minus 1 and x plus 1. And if you draw it, again, you could draw this with a graphing calculator. Again, they switch. From 0 to 1, y equals x is the top function, and x cubed is the bottom. Again, the higher the power, the lower the function. But they do switch from -1 to 0. Sorry, from -1 to 0. So we do have to separate them. Again, from -1 to 0, it would be x cubed minus x, and then plus from 0 to 1, it would be x minus x cubed dx. Again, we can integrate them, and I already worked work this out. If you plug in 0, but then you have to switch the sign if you plug in -1, because these are even powers. If you're gonna raise -1 to the 4th power or 2nd, it's actually going to be positive, but then we switch signs, so that's how come we get -1/4 plus 1/2. And with 1, it's a little bit easier. It's 1/2 minus 1/4. It's a symmetrical function, but everything combines. So 1/2 plus 1/2 is 1. Minus 1/4 minus 1/4, that's minus 1/2. So the final answer would be 1/2. And what are some quick and easy applications, especially in finance and business calculus? Let's say in revenue and cost. Suppose the daily revenue from selling used DVDs is R of t, 100 plus 10t, and the cost is 90 plus 5t. And the interval is from 0 to 5. Find the area between the graphs of RT and C of t in this interval. What does the answer represent? So area would be just, it's kind of easy to see which one's the top one without even graphing, but if you do graph it, maybe switch the window on your calculator. But if you subtract them, that's how come I got 100 minus 90, I got 10, and then 10t minus 5t, I got 5t. And we integrate it from 0 to 5, so we get 10t plus 5t squared over 2, plug in 5, and the final answer is $112.50. So put that in the calculator. And what does this represent? Well, think about it. Revenue minus the cost, it represents the amount of total profit for 5 days. And again, you can actually find it. I put it as a working week, but it's really 5 days. And I can similarly look at this problem, income and expenses. Suppose your annual income is 50,000 plus 2,000t from 0 to $3 per year. Again, we know the rate for the number of years since you began your job, while your annual expenses are 45,000 plus 1,500t, hopefully smaller than your income. Dollars per year from 0 to 3. Find the area between the graphs of I of t and E of t. What does your answer represent? Again, we can subtract them. 50,000 minus 45,000 is 5,000, and I believe it was 2,000 minus 1,500, it's 500t. So we get the actual function here, and then we integrate it. I just put the final answer, so make sure you get that and check it. And what does it represent? The answer represents the total amount you were able to save for 3 years. Because again, if your income is bigger than your expenses, then you do have savings, which ideally that would be the situation. And I believe that's it in this section.